So what we're going to look at in this video is a monthly payment calculation formula. So when people borrow money to make a big purchase of a car or a home or a student loan, they have to pay that money back. And the way it's usually done is via a monthly payment uh, program. And the monthly payment formula is given by this formula right here. There's a lot of variables in there and sort of a beast of a formula. So what we're going to do, we're going to take a look at a couple of examples of how this monthly payment formula works. By taking a look at an example of somebody with a student loan and repaying that student loan on a monthly payment schedule or a monthly payment program. So let's take a look at the specifics of this particular student's student debt. We want to find the monthly payment, the total that they have to pay on their student loan, and the interest that they have to pay on the student loan under these conditions. So the student borrowed $45,000 to go to school. One bank gives them an interest rate of 4% and 5 years to repay that loan. So let's take a look at using this formula under these conditions to see what the monthly payment is going to be. The A in the formula is $45,000, how much they owe for their student loan. The R is their interest rate, 0.04, I converted that to a decimal. My N value is always going to be 12 because it is a monthly payment. N is going to be 12 for a number of months in a year. So I have 1 minus 1 plus 0.04 over 12. I'm working here in the denominator. Minus 12 and negative 12 for my exponent times 5. 5 years to repay the loan. I took this formula and I placed all of the values in for this particular situation for this particular student. Now we have all of these numbers, and the way I like to go through this is I like to just ignore everything in that denominator and just work within the numerator first. When I multiply these two numbers together, I get 150, 45,000 times 0.04 over 12, and then working downstairs in the denominator, I have 1 minus 0.00333 raised to the negative 60 power. So this is already starting to get cleaned up a little bit because it does look intimidating there. We've already started to eliminate some of the mess. Negative 12 times 5 is negative 60. Those two, there's what I have. Now, from here, $150 stays. I have 1 minus 1.00333 raised to the negative 60 power. In my calculator, I come up with 0.81917. So there's my value for 1.033 raised to the negative 60. I'm almost done. Calculate my monthly payment, how much this student will need to pay every month, pay off their student loan. So my monthly payment is $150 divided by 1 minus that value to 0.18083. Their monthly payment, $829.51. So there is their monthly payment given the conditions from start to finish using that formula for 45,000, 4% over 5 years. So that takes care of the monthly payment. Let's take a look at finding out how much they have to pay for the total on their loan. So the total to repay on this loan, sort of a common sense formula or common sense process, they're making that monthly payment, $829.51, and they're making that monthly payment 12 times a year for 5 years to repay the loan. 5 years to repay it, 12 times a year, and there's the monthly payment. the total that they have to pay back on their student loan, $49,770.60. So even though they only borrowed $45,000, they have to repay that, which includes the interest. So the interest on this loan would be their total, $49,770.60. They borrowed $45,000 originally on their loan, so the total they have to pay back in interest is $4,770.60. There's my total. There was the original amount. There's how much I owe in interest alone. Now, let's do the exact same thing, and let's change the numbers up a bit for a different option. Let's say you have a 5% interest rate and you have 10 years to pay the loan back. I am going to solve this exactly the same way with a few little number changes for these particular variables. So instead of 4%, my interest rate is 5%. I have 12 months to pay the loan, 12 payments per year to pay the loan back. There's my interest rate, 5%. Everything is the same, and then suddenly I have 10 years to pay the loan back. So here are my exact same equation with the numbers that have changed to reflect different interest rate and a different number of years to pay the loan back. So just like I did in the previous problem, let me eliminate the denominator so I don't get too overwhelmed. When I multiply the values in the numerator, I have 187.50. Let me start with the denominator. I have 1 minus 1 point. 5 divided by 12 is 0.04167, and I'm going to raise that to the negative 120 power. So there are all of my values for these conditions. Numerator stays the same, 187.50. 1 minus that value that I find in my calculator is 0.607137. So that comes from 1.004167 raised to the negative 120 power, and there is my value there. And that's something you probably want to practice in your calculator. Now, almost done with my monthly payment. My monthly payment, final step in the calculation, is I have 187.50 divided by 1 minus 0.607137 is 0.392863, and that's going to give me 477.27. So there's my monthly payment under those conditions. And notice that it's much less than the 5-year plan because we're spreading out the length of the loan. I don't have to pay that much because I have 10 years to pay it back every month. My monthly payment decreases. Now, the total to repay on this loan, I take my monthly payment, I pay that 12 times a year, this time for 10 years. When I multiply that out, get $57,272.40, which is higher than the 5-year payment plan. I'm borrowing the money for a longer period of time, so I'm going to have to pay back more over the life of the loan. And the interest that I have to pay back, I take the total amount that I have, $57,272.40, and I subtract $45,000, the amount that I borrowed. So the interest for this part of the loan is $12,272.40, which is much higher than that value over 5 years. So paying it back over 10 years, the monthly payment is much lower, but the total amount that I have to pay and the amount that I have to pay in interest is much higher. So there are definitely advantages and disadvantages to each method, depending on which you choose.